Mr. Thomas George, Mr. KSG Shankar, Mr. S.M. Balasubramanian, Mr. Lakshmi Narayan Devraj, Mr. Sajin Sebastian, Mr. Vishwa Akela, and Ms. Shobha C.S. They were also enabled by Mr. S.K. Mishra and Mr. Padmanabhan Naidu, who are not with us here. The baton that they carried would be continued further in the phase of expansion, which is now 2018. I would like to invite our President, Mr. Madhuk Ji, to honor these dignitaries on behalf of the Executive Council of BSPIN. Come to 2018, you can watch us on all the social media channels and handles like that of Facebook, LinkedIn and Twitter. You will experience a new digitally competitive BSPIN. I now request all the current Executive Council members to stand up to receive a thunderous applause from the audience. We now have a series of interesting talks and panel discussions today, and I sincerely hope each of you has a great experience through these sessions. Here is the list of sessions planned for the day. Keynote address by Mr. Srinivas Prasad, Digitalization and IIoT Making It Real by Mr. Chetan C.A. Halli, panel discussion on connected devices, challenges for startups in a digitally competitive world by Mr. Sanjay Koppikar, panel discussion on artificial intelligence, cyber security by Mr. Sunil Varke, Digital Industry 4.0 by Mr. Sajeev Jacob, Making Your Business More Competitive by Mr. Ashok Mysuru, Disrupting the QMS by Mr. Anand Parupkari, Eradicating Preventable Blindness by Mr. Chandrasekhar Kuppuswamy. Let us now start with the keynote address by Mr. Srinivas Prasad, CEO of Philips Innovation Campus. I request Dr. K.K. Raman to chair this session for us and introduce the chief guest. Dr. K.K. Raman is the Chief Knowledge Officer, Advisory and Head of Business Excellence Practice and Global COE at KPMG India. Dr. K.K. Raman did his engineering studies in NIT Trichy and management studies in IIM Bangalore. He holds a doctorate degree in management from IIT Madras. He has over 25 years of rich and varied strategy, management and consulting experience across multiple sectors. He has completed the ISO Lead Assessor course conducted by CII UK and also authorized on CMMI, PCMM and SCAMPI High Maturity Assessments by SEI CMMI Institute. He is a certified SAFE program consultant. As a business leader, he has guided and directed over 200 advisory engagements, reviews and assessments for KPMG both in India and abroad. He has also been an executive member of SPIN, member of European SEPG review panels and a life member of Institute of Public Auditors. Request you to please come over, Dr. K.K. Raman.
Thank you for the kind words. It gives me great pleasure to be back at BSpin. It's a major milestone for all of us as we look back with pride on our past and rededicate ourselves to make the movement more relevant and also more challenging in terms of the changing times where we shift from process to innovation. Towards this, I think it's the right point of time in the day to start with something on innovation. None better than Srinivas Prasad, who is the CEO of Philips Innovation Campus. So Prasad has over 3 decades of experience in various technology companies. Prior to this current assignment, Prasad was Vice President IT at FMR India, and also he has served as General Manager at Sony in India. Before that, Prasad also worked at Alcatel in France and ITI. We were recollecting the early days of CDOT and how it collaborated with ITI. And of course, Prasad has an outstanding academic record with engineering, electronics and communication as well as an MBA. And he has also been a Hindu-Hitachi scholar, published papers in IEEE conferences, worked in Japan and France as well. And very importantly, ardent cricket enthusiast. Not sure if you played for the state. And of course, represented country also earlier in the career. Wonderful. And we are fortunate to have you, Prasad. And please do share your thoughts in terms of future of manufacturing and how do you see innovation occupying the center stage as we go forward. Thank you.
Good morning. Good morning, and I'm humbled by the introduction. Thank you so much, Mr. Raman. First of all, let me congratulate BSpin for the Silver Jubilee. And I do pray and hope that we'll see a Golden Jubilee and a Platinum Jubilee. And I'm sure given the enthusiasm and given the commitment that all of us have to make India the best technology place in the world, and given what I heard in terms of how it started and how it's progressed, keeping pace with the changing times is simply amazing. And let me salute all the people who kicked this off, the people who have been involved in the different phases of BSpin. If not for you, the whole movement that has actually triggered the phenomenal growth in IT and in the technology sector in India, I'm certain it would never have happened the way it has happened. First of all, I salute you and congratulations. We can bask on our past glory, but I think it's even more important to actually prepare for the future. And one of the transformations that's unfolding in front of us, I'm sure all of us are aware, is in the manufacturing sector, what some people refer to as Industry 4.0, some other people refer to as a smart factory. They're good at making different names to confuse people. All of it means the same thing. And what I would like to share with you is some of my thoughts. And I'm sure there are a lot of experts in this room, and I'm not the expert here. I'd like to also learn from you during the break, after the talk or sometime during the day. What I would like to share from you is some perspectives of 4.0. And I think more interestingly, in terms of what we are doing in Philips and how we're approaching it. And thirdly, the challenges that I see, which could be a deal breaker, could be something that needs to be addressed for this big wave of transformation to be successful. So, it's good to always, go back in history. And, every 50 to 60 years, there has been a spurt in growth, economic growth across the globe. And each of these growth have actually been triggered. There have been small spurts, small spikes that have happened. But each of these big spikes, right from the 18th century, right from the 18th, 19th, 20th centuries, have been triggered from the manufacturing sector. And we go back to the 18th century when the first weaving, the hand loom and the invention of the steam engine, which actually triggered a lot of jobs, which triggered the first wave of economic growth across the globe. And if you look at the second wave, it was more in terms of higher employment, the mass production of electricity, and all the world wars, couple of world wars, which happened just prior to that time. And the third growth was more in terms of automation, right? The invention of programmable logic controllers. And I remember in 1989, you spoke about the Hindu Hitachi Scholarship. I was fortunate. It was a very inclusive and very extensive training program at Hitachi. And as part of this, I still very clearly recollect the visit to the Nissan factory. And to me, it was something that, it was something out of the world, with all the robotic arms and the automated conveyor belts. And it was amazing at that point in time. But I'm sure what we are going to see in the next wave is going to be even more amazing. The next wave, what people refer to as 4.0, the name originated from Germany. If you look at the whole of Europe, people refer to this next industrial revolution as 4.0. But if you go to the US, they want to be different. Given Mr. Trump, he also wants to be different. So given that change, they refer to as smart factory. And sometimes there's a connotation of industrial IoT, and that's probably widely used. But the way I see it is probably all three refer to some form of transformation in the industry. Now, the fourth transformation, which is unfolding, is going to bring a big change in the way the transformation is going to happen. Right? It's going to take a couple of decades. It's not something that's going to happen at some point in time and say all of us is going to be done. But it's going to take a couple of decades. And this new transformation is triggered predominantly by technology. Right? And you're going to hear quite a bit of speakers talking about several of these technologies, but I'll just touch upon it. Now, there are four main triggers or changes which I do believe as to why this new wave that we're seeing in front of us will be successful. One is the significant reduction in the cost of computing power. The second is miniaturization, the continuous miniaturization of sensors and actuators, which form a big part of the production system in any factory. The third is more smarter, more cheaper, smart technologies. The fourth, data. Everywhere you go, whether they understand or not, they want to apply analytics, they want to apply AI, they want to deploy things in the cloud, but we'll come to it in a minute in terms of what the challenges would be, etc. So if you look at these 4 or 5 big triggers, is what I would do believe as to why the time is right for the next couple of decades for this new transformation that's unfolding in in the manufacturing sector to really give a boost in productivity. If you go back, when mass manufacturing first happened in the high-cost countries, over a period of time, the cost became a lot more. And the first wave of mass production brought down the cost to some extent. Then the next wave was, the challenge was to how do you bring down the cost of manufacturing. So, bingo, outsourced. So a lot of factories moved to South of America, moved to China, etc. Exactly the same factory, exactly the same process, exactly the same products. Nothing changed for a few decades. But behold, I'm sure many of you know in this room, the cost in China is going up, the cost in Brazil is going up, the cost in India, we have been good at managing, but it's still going up with inflation. And I can tell you from our experience in Philips, the cost of manufacturing in China, including the whole supply chain and the logistics to deliver the product to the rest of the world, is predominantly more or less the same of actually manufacturing in Bothell, one of our factories that we have there. And I spoke to a couple of my colleagues in the automobile sector, and I think everybody has the point I was trying to make. And also, if you look at Brazil, the cost of manufacturing in Brazil, if you look at the labor cost, if you look at the escalation, inflation that has happened there, is more or less very similar to manufacturing in France. So we need to think differently. And invariably the question comes up as to, what are the benefits that the manufacturing sector, and why do we need to do this? If you see, the whole consumer demand and what all of us ask from our products is changing. Customers want customized products. The supply chains need to change. The factories need to adapt to the varying demands. And all this is going to put a lot of pressure in the way we have been actually deploying the processes for manufacturing. If you look at a couple of industries where I do believe, there are a lot of industries which have imbibed these technologies. I'll come to a minute in terms of what I see as the technologies. There are a couple of industries which have done pretty well in adapting them and moving ahead of others. Because it's a journey. It's not somebody who can say, hey, look here, I've done everything, I'm 4.0. No, that doesn't happen. If you look at the automobile industry, I was talking to somebody from the Audi factory, a friend of mine, who's in Germany. And what they have done there and what they plan to do is something amazing. If you look at Audi, if you look at Daimler, if you look at Toyota, if you look at Nissan, if you look at even the factories in China, the advances that they have made in moving towards 4.0, deploying the technologies that are part of 4.0, I would assume there's a lot for us to learn from them. Right? A lot for us as a community to learn the processes, to learn the best practices, and to see how best we can adapt it in the industry. The second industry, which I believe has progressed pretty well, is the FMCG industry. And I go back to the Procter & Gamble. This is not today. Right? Basic diapers. Earlier, you had one type of diapers manufactured as a batch, hundreds of thousands of diapers. But now you have probably 50, 60, or maybe 100 different types of diapers. And also you have adult diapers, for the elderly people. And they have done brilliantly, the way I see, in terms of still managing the cost and adapting their manufacturing processes, maintaining their quality, maintaining their cost, to ensure that still we make it affordable, to the segment of society, to segment of market that are actually selling the product. So different factories are at different stages in this whole evolution that we spoke about. There are different, for example, if you look at the robo, there are probably, other than the mechanical parts of the robo, you have probably a sensor, you have an actuator, and you have a controller. The earlier days, the controller was a programmable logic controller, where you could program it for multiple sequences. You had a sensor, which was probably not that miniaturized, and you had actuators, which were bulky enough. But the first stage where companies are actually progressing is to split this separately with connectivity. The control has gone to a central command center. It could be on-prem or it could be in the cloud. Still, many of them are still having the control on-prem. Cloud is a myth. Some of the sectors have actually moved the data to the cloud. But still, if you look at the sector that we operate in, healthcare, I'll come to it in a minute, still the customer is very, very wary in sharing the data and moving the data to the cloud. I'll just come to it in a minute. So that's the first stage, right? I mean, you can program multiple sequences, multiple arms, so that what that helps you to do is manufacture different types of products, different batch sizes, different speed. So that's the first step. The second is controlling the production line, right? So the sensor from one robo can actually control the actuator from another robo on the production line. Invariably what happened, I still, it's vividly in my mind, when I visited the Nissan and Toyota factories in Japan, you have this emergency button, right? Where if something goes wrong in that part of the production line, you have the worker or the supervisor who, jams the button and the whole production line comes to a halt. Now you need to have an automated mechanism as to whether, you can slow down the previous production line or do things a little differently without manual intervention, right? So that's the second stage of ensuring, all the robos, I'm just speaking robo just as an example. There are multiple other technologies that come to mind. To control the whole production system, to be able to adapt itself to the needs of the hour. It could be multiple products or an issue or a problem, whatever, it's to adapt it. The third is, again, this is an example, from one of the FMCG companies which I picked up from the web. From the time an order is placed in this FMCG company, which I don't want to refer to, for the order to actually get to the manufacturing floor, for the production to start, was taking more than a week's time. So some of the companies are actually looking as to how to automate it, and this company actually gets the order now in less than a day to the production floor. Right? So how do you apply technology? What do you need to do upstream to actually capture the orders and get it to the production floor so you can get the product out and get it out to the end customer as quickly as possible. The third is control between multiple factories. Right? I mean, if you look at 4.0, the manufacturing will move closer to the customer. So I'm actually very curious to see. I think it's anybody's guess. I have my own views, but I would really want to see in the next probably couple of decades in terms of how the whole landscape pans out. Because right now, if you see all the factories are in low-cost countries where there's mass production. We also know that Samsung is going to set up something, very big in India for the mobile phones. But I think it would be very interesting. So the whole shift would be, if there is a problem in a factory, something comes down, how do you very quickly shift and look at a spare capacity in some other factory and get the same product done there, though it's not customized for that product. So how do you connect all the factories and build that intelligence to actually get the best product out at the fastest time? So I can go on and on, but I'll stop there. But this would lead to many benefits. Right? I mean, one is you're automating a lot of stuff. So a real spike in productivity. And I'm curious to see as to how it will impact labor. And if you look at the production cost, if you look at the US, if you look at all the premium countries, the advanced countries, I could be off by a bit, roughly 60 to 70% of the cost is labor cost, and remaining 30 to 40% of the cost is the electricity, gas, and other costs. Right? But if you look at a country like India, 25 to 30% of the cost is labor cost, and the remaining is electricity, gas, and the other costs. So the impact of the benefits and what we would accrue in each of the economies globally is something that needs a lot more thought. And I think as an industry we will benefit, but again I'll come to it in the end in terms of we need to think a little more deeply as to how this wave is going to impact us. We're still not in the manufacturing hub of the world. We're not the manufacturing. A lot of companies are moving here, so we just need to figure out, and I'll come to it in a minute. Of course, a lot of flexibility and customization, because again, you can, if the controller is separate, and you have flexibility in terms of how you can run the production line, so you should be able to even manufacture a product and have a product line for one product, right? And that's a flexibility that I would see the customer would demand as we go forward. Better quality of output, of course, there are craftsmen. We pride ourselves. I was talking to somebody in terms of the craftsmanship that in India that we had, looking at all the heritage sites and all the beautiful temples that are there. Somewhere that craftsmanship we have lost. But of course, manual labor, as we see, in some areas it's good, some areas is a lot more quality, that's an improved. And of course, improved worker safety. Right? In industrial environments where safety is a huge concern, co-working with robos, getting the tasks which are not that safe to be done by robots, is a big benefit that you would see from a manufacturing front. Of course, with the evolution of sensors, the evolution of analytics, the evolution of the more the data you have, the more the analytics, the more the predictive capability that we would have. And this is where you would see significant benefits accruing from the wave that we see in front of us. I'll just spend a few minutes because I think I'll talk about it, in terms of what we're doing at Philips. All of us have heard about all these technologies. We try to talk about, robotics, and there's a huge growth that you would see projected, by, you have some very big robotic companies. Like, for example, Fanuc in Japan. They're investing a lot of money in making the robots more intelligent. You have car seat manufacturers, because the automotive industry is moving up the value chain. So the demand would be in all the suppliers to also implement 4.0. But being an SMB, again, that comes with its own challenges. Your parent that you work with. So there'll be a set of dynamics in terms of how these technologies will be deployed. AI adoption, there's no doubt that AI, machine learning, deep learning will play a huge part, not just the manufacturing sector, but in everything that we do. But given the benefit that the industry would get in automating and cutting off manual labor, the benefit there would be a lot more huge. So the way I see AI, of course, it will play a huge part in the revolution that is unfolding in front of us, but that will be more an evolution rather than a revolution. Right? That's the way I see it. It will play a huge part. 3D printing, more additive printing, and this is something which was actually very interesting to me. If you look at the aerospace industry, the fuel nozzle, though we think of it, as for us, fuel nozzle, at least for me, the fuel nozzle is the nozzle in our scooter or in our car, which is not so complex. It has multiple parts to it. Earlier, the way it was being done in, I think, Airbus or Boeing, I forget which big company it was. It used to take probably a week or a couple of weeks to actually manufacture one fuel nozzle, because you can't go wrong. If you're up there in the air, something goes wrong, all of us will be very quick on the ground. And now with 3D printing, additive printing, the whole thing happens in less than a day. Let alone the cost, but the crash in time to market and the ability to be more flexible into more things with what you have is amazing. So I would see a lot of, even in Philips, we use a lot of 3D printing. I'll just come to it in a minute. I will not talk about IoT. I understand there is another session on IoT later during the day, but the way I see it, at least in India, the electricity and the gas cost and the other costs that will be there has a huge opportunity to leverage IoT connected devices to actually bring down those costs, right? To save energy in whatever way we can. So that's a huge opportunity for India. And this is very interesting, which, again, a concept I'm sure many of, the digital twin, right? When you've automated the factory, and you're going to have hardly few people manning the factory, you need to ensure that you have a digital twin, whether it's a simulated twin or a physical twin. And if you go back to the time of Apollo 13, all of you remember Apollo 13? The problems that they had, and it was a miracle that they actually came back to Earth. And if you go and read about it, it's a fantastic story. They had a simulated and a physical model of Apollo 13 in the NASA labs, which they actually worked on and tried different things. Again, triggered the motors, got the spacecraft working, and all the astronauts were able to safely come back home. So I see the same concept very prevalent, and which I would see in the future, which would be required to ensure that the downtime of any of the machines in the factory or the machines which are there at the end customer site, you need to actually fix it very fast. And you can't shut down the machine, but you still need to be able to predict a problem before it happens. Right? So these are few technologies where AI will play a part, analytics will play a part. So these are few technologies which I would see are going to be very prevalent in the transformation that's unfolding in front of us. So I'll come to Philips. I'm not sure how many of you know about Philips. I'm just going to spend a few minutes on Philips because I think it's important for the context of what I want to share. Philips is a 125-year-old company, right? And it was a consumer electronics company, a lighting company. I'm not sure how many of you know today that we are a healthcare company. All the consumer electronic products, the TVs, the audio, and all those products are actually brand licensed. We don't manufacture them anymore. The lighting, which was probably the brand with which Philips is known to all of us as kids, the Philips radio and the lighting, is no more a Philips company, though we have a stake in the company. It's been actually part of